Okay, sometimes getting your null hypothesis and alternative hypothesis can be tricky. Now what they're going to do is they're going to test the sweetness before storage minus after storage. So it has a high score before storage and a low score after storage, and you subtract them, you're going to get a positive value. Okay, so let's start with that. Now, what we're going to do is our null hypothesis is, remember, that's no change. And we're using a mean here, so we're going to say the parameter of interest is 0. And then we're going to say that the alternative hypothesis is going to be that it is larger than 0. Okay, and then we're going to use a t-test, a one-sample t-test for this. So we need to do, remember, random, normal, independent. Now let's see, is it random? So if we look, let's see, found by, right here, tasters from a random sample. Okay, so that's okay. And then is it normal? Well, let's skip that one for a second. The independent, right here, is okay because we're going to assume that there's over 100 colas that you could test. The 10% rule. Now what we're going to need to do is put these into L1 because there's less than 30 and do a box plot and see what the box plot looks like. So this is what I came up with. It looks like this. It's skewed a little bit to the right, but it's still okay because, what's the word? It's robust. Okay, it's robust against skewness, but not against outliers, unless it's super skewed one way or the other. So we're good. And remember, that's for normal. Okay. So now we can do the test. Let's do the math part. So using one variable statistics over in list 1, I get this. Here's my average against what I think it should be here, or what they say it is, or what we think it might be. Anyway, and then here's the standard deviation divided by the square root of our sample size. So let's see what number that is. So I get a value of 2.71, or something close to that. What am I going to do with that? So I got to figure out, what is it, TCDF. Couldn't even find that today. Where is it? Hold on a second, let me look. So second vars, and number 6 is TCDF. I put in -1000, and the upper is 2.71. Degrees of freedom is 1 less than how many values I have in my list, so that's going to be a 9. And I get 0.988. So I got to subtract that from 1, because we want to know what's bigger than that. Subtract it from 1, and I get a value of 0.0119. So there we go. Our p-value, I guess you would say, is p-value is going to be .0119. Now, they don't mention the alpha level, so we're just going to assume that the alpha level, I think I forgot that in the beginning here, alpha level is going to be 0.05, which means this is smaller, and we are going to reject the null hypothesis in favor of the alternative hypothesis, meaning we think that the cola is losing flavor after storage. Now, I didn't write a lot of that stuff down, but you guys need to, when you should practice it. We only have 2 of these big questions for homework. Do the state, plan, do, conclude. Also, one last thing before we go to the next one. Right here, whoops, right here, don't forget that if you want to look at what it should look like, there's an example on page 571. Okay, let's do the next one. Okay, so they give us a bunch of information on this bone density, like this mini tab is what they call it. They tell us how many are in the sample, and they even tell us the null hypothesis and alternative hypothesis, the mean and the standard deviation. But let's talk about letter A, which is the IQR. Now, you might have forgotten how to figure that out. So the way it's done is we take Q3 minus Q1. That's going to be called the interquartile range, the IQR. Now, what we're going to do with that is we're going to take the IQR that you just found and multiply it by 1.5. So, let's just do that right now. So, here it is. Here's the IQR. I took, where is it? Q3 and Q1 and subtracted them and got this number and multiplied that number by 1.5 and got this. Now what we do with that number is we add it to Q3. So let's do that. So we did that. We added this number to Q3. Now what we look for is, are there any numbers that are bigger than this? So we look at the maximum, which is not bigger than that number, which means there's no outliers. If there were numbers bigger than that, we would say there's an outlier. Let's look at the minimum. We're going to do the same thing, except this time we're going to subtract this number from Q1. Now, let's take a look at what that looks like. Well, actually, you can look at it and just take 687 and Q1 is 632, which would be pretty, it's going to be like a negative number, right? Which means that our minimum is fine. There are no outliers. So, no outliers. Okay. So, that's just kind of a review of how do you figure out an outlier. Now let's look at letter B. Interpret the p-value in context. Well, check this out. Right there, there's the p-value. It's pretty much 0. Okay, so we are going to end up rejecting the null hypothesis. Okay, so what does that mean? It means that we have about a 0 chance of getting a sample like this if this is true. Okay, which is why we reject it. We have a 0 chance of that actually happening just by chance. If this is true, that's what the p-value means. Okay, let's look at letter C. Actually, let me read to you what the answer book says for letter B. I just looked it up. If the mean daily calcium intake for women 18 to 24 years old is really 1,200 milligrams, then the likelihood of getting a sample of 36 women with a mean intake of 856.2 milligrams is roughly 0. You have a 0 chance of that actually happening. Okay, so let's do the next thing. Now on letter C, they give you a bunch of the information already. It would be awesome. I'm not going to do it. I'm not going to do the state plan, do, and conclude, but it would be fantastic if when I look at your homework for letter C, it's good practice that I see that. Okay, now, but let's talk about how we would do this using a calculator. I'm just going to press stat over to test down to a t-test, and this time I'm going to use stats because they give us all the information. So I'm going to plug in for, now if you want to follow along in your calculator, u sub 0 is going to be the average for the parameter of interest. So that's going to be 1,200. And then what did we get for our sample? Now that's going to be over here. The mean is 8, so x bar I'm going to put 856.2, And the standard deviation, they also give us 306.7. And what do we want to calculate? And it shows us right here, it's a less than. So we're going to highlight that and then go to calculate, and it gives us all the stuff. I almost forgot n is in there, so n is 36. Anyway, I'll give you a picture of what came out. Okay, so if you go to the t-test, like I said, here's all of the information that they give us in that mini tab. You just kind of do it, and it spits out these numbers. Now, this is very far away from our average, over 6 standard deviations away, which gives us an extremely small p-value. You might be confused at this number, but it's e to the negative 8, which means it's really 0.0000004, super small number. So almost no chance of that happening, which is why we reject the null hypothesis. And I just noticed, awesome, swastika, and that's scratched into the screen of the calculator. Why are some people so horrible? That's my question. There's no answer for that, but we're going to stop right there, and I'll see you tomorrow.